Example 2 of using the Pythagorean theorem to classify triangles. This is always done in 2 steps. The first phase, you have to decide if these 3 sides can even form a triangle. To do that, I'll look at the 2 smaller sides, which I will call legs. I will subtract them and add them. So I take 5 minus 4, pardon me, which is 1, and then I add them. 4 plus 5 is 9. Now, thinking of this as a shading, this would include all numbers that are bigger than 1 but less than 9. And I'm asking myself, does 6 fall in that interval from 1 to 9? It does. Since 6 falls in that interval, I can conclude I do have a triangle. So I say a triangle exists. We call that the triangle existence theorem or postulate. Triangle exists. And then phase 2, I'm going to apply the Pythagorean theorem. As I apply the Pythagorean theorem, I'm not going to state that these are equal. I'm going to see what kind of relationship exists. They may be equal. And so I say my legs are 4 and 5. 4 squared plus 5 squared. And I'm going to question, how is that related to 6 squared, the hypotenuse along a side squared? So I'll do a little bit of math here. 4 squared is 16. 5 squared is 25. I still put a question mark here because I don't know how this is related. 6 squared is 36. Now that I add the 16 and 25, I get 41. And I ask, how is 41 going to be related to 36? 41 is greater than 36. As I described in the last video, which I'm going to do again in this video, we want to look at this relationship and try to figure out what that means. Think about being set in stone. You've got this distance that you need to span. If you had a short little person that come up and had to span this distance, they may have to really spread their legs out in order to put a foot here and a foot there. If they did that, they would create an obtuse triangle, because this angle in here would be greater than 90. If they were perfectly able to, maybe they have one leg longer than the other, maybe they were able to create that right triangle there, okay? Which means that these legs perfectly fit to create a right triangle. In the third scenario, same distance, maybe you had somebody who was really, really tall. And so it didn't take them much to be able to span that distance. This angle up here would be acute. So this is an acute triangle. This would be a right triangle. And this would be an obtuse, an angle that's greater than 90 degrees. So an obtuse triangle. And the results of this is saying, if our legs are short, we'd have L squared plus L squared being less than the hypotenuse squared. That doesn't fit our scenario. So it's not an obtuse triangle. If leg squared plus leg squared was equal to the hypotenuse squared, we'd say, ooh, that's the right triangle. That's the one we're so used to using at this point. And the third scenario, if you had the leg squared plus the leg squared being greater than the hypotenuse squared, means you would have to have this acute triangle. And that matches our scenario here. So for this particular set of sides, 4, 5, 6, it's telling me not only do I have a triangle, because I applied the existence of a triangle, that concept, I have a triangle. I can now classify it because when I squared the legs, the result was bigger than the hypotenuse squared. It tells me I must have an acute triangle. So I can say this leads me to an acute triangle. I have an acute triangle. That's example 2 for classifying triangles using the Pythagorean theorem.